All right, welcome back. We are on part G and H. Yeah, we do both because G is quick. Okay, so I wrote down all of the information we need to do this, and so now let's do it. Plug in optimum values for pi and e pi, expected pi, into the economic output function. Check, let's do it. Economic output function is this one, yn, plus a. Now we plug in pi star. I mean, look, let's not actually plug things in. Let's just use this fact right here, that pi star, and then e pi, expected pi star is pi star. So minus pi star plus epsilon. And then we just get that y, because this is 0. This is 0, of course, and we get y n plus epsilon. So now it asks us what happened. Well, the central bank had this idea that it was going to choose non-zero inflation because this term would be positive, right? That was the whole reason why it chose non-zero inflation. But after the households incorporated the choice of the central bank into their own expectation, it thwarted the central bank's plan, and there was no additional growth. So in the end, the expected growth is just equal to the natural rate of growth. We didn't get any benefit from the choice of non-zero inflation, this choice. So instead of inducing economic growth, the central bank raised inflation and growth remained at yn in expectation. So bummer. And that's because the central bank didn't take into account the dynamics of the households. So this is sort of like, it's not sort of like, this is exactly the kind of situation that the Lucas critique is thinking about. The economists at the central bank wrote down a model. They assumed that the model was static. They optimized the function. They optimized the model. They used the model to make economic policy. But their assumption of staticness was wrong. So the households react to the central bank's choices and their use of the model, which the households know. And it thwarts everything, and so we get inflation and no growth. So we can actually quantify how bad the situation is. And this is part H. Part H. H says, find expected welfare of the optimal solution. So we're going to take the central bank to be the social utility. I mean, really, we can think of utility, social utility, as the utility of the central bank plus the utility of the households. Okay, so we're going to add up everybody's utility in the whole economy. We know that household utility is always 0. How do we know that? Because we drew those parabolas, right? So at maximum, where we are, we're at the maximum because we're setting this and this. So at the maximum, this is going to be 0. So we only need to worry about the utility of the central bank in this stylized economy. So we're going to plug in, y star, which is this, and we're going to plug in pi star, which is this, and we're going to compute what is the utility of the society. So big U equals UCB plus UHH. Okay, and then we plug in everything. I guess one time I'll actually leave the UHH and we can just see that it comes to 0. So UCB will be lambda times yn plus epsilon. And then minus 1/2 lambda alpha squared. So again, this is y star. This is y star. So much stress about color choice. This is y star, and it comes from right here. It comes from right here. And this is pi star, and it comes from right here. Okay, now we add to this UHH at the optimum. So UHH is, well, it's negative, so we plus, but then it's minus 1/2 times expected pi star is pi star, and pi star is pi star squared. Okay? So now we see very, very clearly that this one is 0. So we're left with u is equal to lambda yn plus lambda epsilon minus 1/2 lambda squared a squared. And we need to take this in expectation. So we're going to take expectations of both sides. Why do we need to take expectations? Because we have a random variable. And when you have a random variable, you need to say something about, you have to say something. You can't just leave this epsilon here and say, like, okay, I'm done. What does that mean? So we can take an expectation to summarize, just kind of remove the random variable and sort of say, what is our best guess of the utility given everything that we know? So that will equal the expectation of lambda yn. Now expectation is a linear operator, so you can split it over addition, lambda epsilon minus expectation of 1/2 lambda squared a squared. And the next thing you can do with expectation is factor deterministic things out of it. Okay, so first off, the expectation of lambda yn, this is not random. Okay, there's no randomness here, so our best guess of what that is what that is. Okay. If I tell you that x is 1, and then I ask you to give me your best guess of x, well, you tell me it's 1, of course, it's always 1. Here I told you can factor the lambda outside of the expectation, and then we're just left with the expected value of epsilon, which is random. So we need to come back and remember, I didn't write down our distributional, is that this follows a normal 0 sigma epsilon distribution. So the expectation of a normal is just the mean. It's the first parameter, 0. So this is 0. So we get plus lambda expectation of epsilon, which will be 0. Which will be 0. And then to this we add, or we subtract. Again, we have 1/2 is deterministic, lambda squared is deterministic, a squared is deterministic. So we get minus 1/2 lambda squared a squared. Okay, and so this is expected utility. This is expected utility given the optimum values for pi star and y star. Well, it's kind of ugly. I shouldn't have boxed this one, I should have written it again. So it's yn minus 1/2 lambda squared a squared. Okay, now imagine that somehow we change the model so that the bank chooses pi star equals 0. Okay, we're not going to motivate this with math. We're just going to say, just imagine that they chose pi star equals 0. What would be the expected utility? So we still have that the households choose expected pi equals pi star. We're just going to forcibly set this value to be pi star equals 0. Okay, and then what do we get? Let's go back to the expected utility. If pi star is 0, then this term will go away, right? UCB. So if pi star equals 0, then the social utility will be the UCB at 0. So we'll get lambda y minus 1/2 pi star squared equals lambda y. Okay, and the UHH is still 0. It's always 0. Okay, so what you can see, yn, I apologize, yn. Yes, I suppose I skipped some steps. So we'll have lambda, and then we'll still have yn plus a pi minus pi epsilon. This is all 0, so that goes away, and then we'll have epsilon. Okay, and then we'll take the expectation of u, and that will be lambda yn. So why did we do this? Why did we do this? Because now we can see that there's a loss term in the expected utility given the bank's naivete. This So we can interpret the expected utility coming down here. This is the expected utility if the bank chooses pi equals 0. You see? It's the same thing. So this is like the base loss that exists in the economy, or the base utility that this economy produces. And then this term is the like loss to naivete. Something like that. How do you spell naivete? I have no idea. So this is like the loss to naivete, that the bank tries to do this tricky scheme to pick inflation to make the economy higher, the households thwart it, and then the price that everybody pays is this term. Okay, so this is the answer to H. If I plug in the values, I get this expression. So this is the first part down here, and then it asks, is this the best outcome? Is the outcome of this game the best social outcome? No, it's not. The best outcome would be if this loss was equal to 0. So if the bank chose pi equals 0. And if not, what would lead to a better outcome? I guess so. Is this the best social outcome? No. And if not, what would lead to a better outcome? A better outcome would be if pi star equals 0. Okay, so we're done. And I'll see you in the next video.